All right, students, we are in lesson 76 of Algebra 2. And this time we are going to use some things that we already know. We're going to put together both substitution and elimination to solve a system of equations. So I'm just going to jump right in here to this problem, 76.1. And here's the thing, you already know how to do all of this. We're just combining some things. So because of that, I'm going to write these equations. Now you're going to have 3 equations, and you're going to have 3 variables. And here's the second one. And because I am confident in your ability to intuit, I know that you guys have developed a kind of a math intuition at this point. I've seen it. You guys are so smart. I am going to let you look at these and solve them yourself. I want you to solve for x, y, z, okay? And you're going to write it like this, x, y, z, okay? When you give me your solution. So I want you to pause the video. I want you to write these down, and I want you to solve for x, y, and z using these 3 equations. And you're going to use both substitution and elimination. And I want to see how far you can get on your own using your math intuition that I know you have developed by now. All right, so go ahead and pause the video. And then when you're ready to see the answer, press play. All right, so I'm going to assume that you have paused, solved it, figured out that you already knew how to do it, and you just want to check your answer. For those of you that it's not the case, you don't have to tell me who you are, but we're going to go through the problem together. All right, so the first thing I see in looking at this is that I already know what x is. X is equal to 2y. So that's easy to substitute in for. So I'm going to take this first one. Let's call him A, right? And we'll call this guy B. And I'm going to write A down here, and I'm going to say x. Actually, I'm not going to say x. I know what x is. X is 2y. So I'm going to say 2y for x plus y plus z equals 9. Now I can combine these and say 3y plus z equals 9. So there's my first equation that is simplified. I'm going to write him over here. 3y plus z equals 9. All right, now I'm going to take B, the second one, and I'm going to sub in the value for x. And I'm going to say 2y minus 3y minus 2z equals negative 8. So I can combine these two and get negative y minus 2z, let me make this look more like a y, equals negative 8. So there's my 2 equations that I came up with. So this is negative y minus 2z equals negative 8. All right, so what I'm going to do, I'm going to solve with elimination on these two. So what I'm going to do is I'm going to multiply this one times 2. So this is a negative and a positive z. So this becomes 6y plus 2z equals 18. So these two eliminate. This becomes 5y equals 10. Divide both sides by 5. Y is equal to 2. So I can write this y is 2. Okay? Now, guess what? I could solve for x because x is equal to 2y, so x is equal to 2 times 2 because that's what y is, so x is equal to 4. So I can take my little eraser and then I can put 4 right there. Now though, because I know what y is, I can pick one of these. I think I'll pick this one and solve for z. So negative 2 minus 2z equals negative 8. So if I add 2 to both sides, negative 2z equals negative 8. Divide both sides by negative 2. Z is equal to, oh, no, that's not right. I made a mistake. That should be negative 6 divided by negative 2, which would be 3. All right, I didn't do my calculation here. So Z is 3. So if you got 4, 2, 3 for X, Y, and Z, then you did it right. And you did the math without me showing you how to do it first. You intuited what you had to do. You have a math intuition if you were able to get this without me telling you how to do it first. So bravo. You should be proud of yourself if you did that. Let's move on to 76.2, and I'm going to let you do that one on your own as well. So 76.2, here are our equations. I am losing my mind. Okay. I'm writing them down. Should be our. My southern accent makes it sound alike sometimes. All right, there's the first equation. Here's the second equation. And here is the third equation. And I'm going to let you guys figure that out for just a moment. Think about it. See what you can do. Make a plan. This is where you look at your equations and you make a plan about what to do while Miss Tracy checks her text messages. Oh, cool. All right. Here we go. Let me see. I got another message. Oh, nice. It's a coupon. Anyway, let's move on. What's the first thing you see? I see this. Don't you see this? If I add this to both sides, right? Then x is equal to 3z. Isn't that our substitution that we can put in for these other two? So let's do that for this one. We have x is 3z, so 2 times 3z plus 2y minus z equals 12. So 6z plus 2y minus z equals 12. So this is going to be 2y plus 5z equals 12. That's as far as we could take that one. So now let's do this one. That was A. This is B. So this was A. All right, now let's do B. And we know what x is. X is 3z. So we could say 3 times 3z instead of 3x minus y plus 2z equals 21. So 9z minus y plus 2z equals 21. So we could say 11z minus y equals 21. Now we have our two equations that we can use in elimination. So we're going to take these two and we're going to rearrange them just a little bit because they're not in the same order. So I'm just going to flip-flop this one to make it the same as this one. All right, so I'm going to say 11z minus y equals 21. And I'm going to take this one and change the order to 5z plus 2y because they're both positive, so it doesn't matter, is 12. Now I see right away that I need to multiply this one times 2, right? So I can get the same value here that I can eliminate. Excuse me, sorry. So it's going to be 22z minus 2y equals 42. So this is going to be 54. These are going to go away. And this is going to be 27z. If I divide both sides by 27, I get that z is equal to 2. So there's my first value. But x is equal to 3z. So since I already know what z is, 3 times 2, x is equal to 6. So now I can go ahead and put my little parentheses up here. X is 6. We don't know what y is yet, and we know that z is 2. All right, so now I'm just going to take this right here and solve for y. So I'm going to say 11 times z is 2, right, minus y equals 21. So 22 minus y equals 21. So if I subtract 22 from both sides, I get that negative y is equal to negative 1. We know we don't like to have a negative, so we just envision that negative 1 right there, and we divide both sides by negative 1, and we get that y is equal to 1. So we put our 1 right here. And that is how we find our answer. So if you're having any struggles with that, please let me know. It should be fairly easy to combine those for you guys. All it is, it's actually making it a little bit easier for you to get to your elimination. It's just making it, giving you a way to get one of the variables out of the way first so you can go ahead and do the elimination part. All right. Okay, so let's move on to negative vectors. If you remember in lesson 72, let me get out of here and clear the page. Remember, especially those of my students who are new this semester, if I'm going too fast, pause the video or rewind it if you need to, and then pause, and then write it down, and then press play. All right, take your time. Because it's a video, you have the benefit of being able to slow me down, pause me, or fast forward me. So you can't do that in class. In class, you have to take me at whatever speed I come, but on the video, you get that extra advantage. So in lesson 72, we noted that there was, only one way to use the rectangular coordinates. For instance, let me see what we have here. We have 8.66r plus 5u. That's supposed to be u, Tracy. All right, so these are rectangular coordinates, right? So rectangular coordinates. I'm not going to write out coordinates because, yeah, I'm just not. All right, so there's only one way to write those, and that's because we can use the negative symbol if we need to, but they are where they are in relationship to the x-axis. There's no changing that. It's all about where the positive x-axis is. Well, polar coordinates are, you can write them two ways, and we learned that in lesson 72. We learned that you could rewrite this, we could transfer that into a polar coordinate, and you would get the length of your hypotenuse and then your degree of measure. Now the positive side we learned was when you are measuring counterclockwise. That means from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4 on the coordinate plane. And we learned that the length stays the same, that doesn't change. But then you could also do it measuring clockwise. So you could measure from the x-axis and go to quadrant 4, quadrant 3, quadrant 2, quadrant 1. So the opposite direction, right? This one measures this way, and this one measures from the x-axis. This one measures this way from the x-axis, right? And it's going to be a negative because it measures in the opposite direction. And this would be 330. So the negative is what tells us which direction it's going. If it's negative, it's clockwise. But it's the same exact point on the circle, so these two degree of measures just ignore the negative. When you add them together, they should be 360, and they are. So that's how they're the same point. It just says that this one is negative because it's going from here around, whereas this one's going from here around the other direction. So we learned that, right? That's kind of cool when you think about it, that you could write it either direction or either way, and you could get the same answer. So we are going to learn how to add these together, two different vectors, as we call them, vectors or polar coordinates. We're going to add them together. And what we're going to do with our first problem, let's move down to the graph paper because it's just so much easier to do this on graph paper because we can see what we're doing and because Miss Tracy can actually draw a straight line that way. So let's put a little graph together that we can use. All right, and then in 76.3, we are going to add these vectors together, -20 degrees, and this one is a +5 and 135 degrees. We're going to add these together. How are we going to do that, Miss Tracy? That looks really stinking hard. And why the heck is that length negative? Length cannot be negative. I get what you're saying. So let's look at it and see what we got. All right, so let's start by drawing our vectors out. We lay out the angles first and then the magnitudes, right? So this is a -20. So it's going to start from here and go this way. So this is going to be right here. This is, this would be a +4 at a -20. But a -4 at the same degree is going to be flipped. It's going to be flipped over here. So that's what it means by a -4 at a -20. So the -20 tells me it comes here 20 degrees. It comes clockwise 20 degrees. And then the -4 on the length tells me it flips from the positive side to the opposite side, or whatever side it's on, it's flipping over here. So this is going to be 20 degrees because, right, these are the opposite angles right here. So this is 20 degrees and this is 4. Right? Ah, yes. Now, we don't use the negative when we talk about the length of the hypotenuse because the length, again, just like we already know, isn't negative. So once we flip it, it's no longer negative, right? So there we go. That is what we're doing. This is the old one. This is the one that we used. Let me get the smaller little thing here. This is the one that we used to figure it out, right? This is the one it actually is. So now we have our right angle, our right triangle here, and our vector here. All right, this is 4, this is 20 degrees. We have to figure out what this is going to be a -r because it's on the left side, and this is going to be a positive u because it's above the x-axis, right? We've already figured that out. So what we're going to do is we are going to use the sine of 20 degrees for this, because sine for the u is opposite over hypotenuse. That's so, right? So always write it if you can't remember. So ka toa, right? It's opposite over hypotenuse. So the sine of 20, the opposite is u, and the hypotenuse is 4. So we're going to multiply everything by 4 to get rid of the denominator. So that's going to be 4 times the sine of 20 is going to equal u. So we pull up our calculator and we put in 20 and we get the sine of 20, 0.342, and then we have a 0, so we stop at 0.342. Okay, so 0.342. Let me clear this. 0.342 times 4 is 1.368. I'm going to round this up to 1.37. I'm going to just round it to 1.4. So 1.4 is u, right? So we can write this one right here, -4, -20 degrees is going to be the same as, let's put in our u. This is a positive u. It's a positive 1.4 u. All right? Awesome. All right, so there's that. And now we are going to do this is 1.4. So now we got to do the negative r. So we know we can use cosine for that because that's adjacent over hypotenuse, and adjacent is the side that helps make the angle. So let's do the cosine. The cosine of 20 is equal to the adjacent, which is the negative r, right, over the hypotenuse, which is 4. So we're going to multiply both sides times 4. So it's going to be 4 times the cosine of 20, whatever that is equal to negative r. So we're going to pull up our calculator, clear this out, and we're going to put in 20 cosine. All right, we have 0.939. All right, we can round this up to 0.94. 0.94. Let's clear this. 0.94 times 4 is 3.76. I'm going to round that up to 3.8. So 3.8 is equal to negative r. So we don't want this to be negative. We don't want a variable negative. So we multiply everything by -1. We get negative 3.8 equals r. So negative 3.8 plus 1.4u is this one. All right, so we see how we got that first. So now let's do this one, and I'm going to draw another little graph here for the second one, and I'm going to write it down here. 135 degrees. Okay, so we know it's positive, so it's measuring from this direction. So that is going to be less than 180, so it's going to be over here somewhere. But it's more than 90, right? So it's going to be in this general area. So we're going to go ahead and just stick it over here. And we're going to subtract 90 from this so we could figure out what the degree of measure is from here to here. So minus 90 is going to be 45, is that right? Yeah, so that looks right. That means I've drawn my angle exactly right. How about that? So 45 degrees. So this is going to be 45. Well, if this one is 45, then this one is 45, right? And we know we have to have the angle that connects to the x-axis. So we're going to do that. That's the angle that connects to the x-axis is 45. 45 and 45, so that's fine. So this is still negative r, right? And this is still positive u. Okay, so we do the same thing we did. We do sine and cosine, only this time we have 45. So the sine and this, let me erase this right here. This right here, we need to have the hypotenuse written in, so this is 5. That's our hypotenuse right there. So the sine of 45 is equal to, that's the opposite, so that's going to be u over 5. So we're going to multiply everything by 5 to get rid of the denominator. So 5 times the sine of 45 is equal to u. Let's pull up our calculator. We find 45, we get the sine, we get 0.7. That's where we're going to stop. 0.7. Pull our calculator back up. 0.7 times 5 should be 3.5, and it is. So 3.5 is equal to u. So this is equal to a positive 3.5u. All right, so now let's do the cosine. So the cosine of 45 degrees is equal to the adjacent, and the adjacent is negative r over the hypotenuse of 5, right? So we are going to multiply everything by 5. So 5 times the cosine of 45 is equal to negative r. So let's find out what that is. Okay, so 45 cosine, it's 0.7 again, which makes sense because it is a 45-degree angle, right? And that's halfway. So it should be about the same for both of those. So 0.7 here. So 5, we already know that 5 times 0.7 is 3.5 from down here. So 3.5 is equal to negative r. We're going to multiply both sides by negative 1. So negative 3.5 equals r. So we can fill that in. Negative 3.5 r. Right? Now, this is where we actually do this part of the equation, where we add them together. So we put, I'm sorry, there should be an r right there. We put negative 3.8 r plus 1.4 u. I'm going to write that bigger so you can actually see what I'm doing. Negative 3.8 r plus 1.4 u, that's the first number, and we're going to add them together. That's this operation here. Negative 3.5 r plus 3.5 u. So what do? Like terms. We add the r's together, then we add the u's together. So 3.8 plus 3.5, they're both negative, so we add them and keep the same sign. That is going to be 7.3. Yes, negative 7.3 r. And then we have 1.4 and 3.5, so it's plus 4.9 u. And that's exactly what the book has. Hallelujah, we got it right. Good job. So you see, we can do this. It's just a long process. We have to figure it out. But we understand now how this negative right here works. When you have the negative length, it just means to flip it to the other side and put your point there. Okay? So measure your angle down to where it goes because it's negative and you're going clockwise instead of counterclockwise. Here we went counterclockwise. We measured around to 135, right? Which happened to be 45 degrees from the x-axis. In this case, we did 20, and the negative 4 is what told us to flip it to the other side. So that's how we did that. All right, we have, let's see, nothing else to do in this lesson. That was it, which is good because this really took a long time. So I would hate to do another one and take even more time of yours because I know that you understand this and you see the concept of what we're doing. So if you have any questions about it, please let me know and we'll go through those, and then I will see you in lesson 77.